For centuries, humanity has looked to the cosmos with wonder. We've mapped galaxies, understood the life cycles of stars, and even pieced together the story of our universe's birth in the cataclysm we call the Big Bang. Yet, for all our knowledge, the universe is still defined by its profound mysteries. Two of the greatest are dark matter, the invisible, unknown substance that makes up most of the universe's mass, and the Big Bang itself. What exactly happened at that moment of creation? And what could possibly have come before? Today, we explore a theory so radical it sounds like science fiction, that our universe is not alone, but is mirrored by an opposite anti-universe, running backward in time from the Big Bang. A theory that suggests these two great mysteries might solve each other. First, let's ground ourselves in the problems this theory tries to solve. Dark matter is the ghost in the cosmic machine. We cannot see it, touch it, or directly detect it, and yet we know it's there. We see its gravitational pull holding galaxies together, its immense gravity bending the very fabric of space-time. It forms the bulk of the matter in the universe, the hidden scaffolding upon which the visible universe is built. But what is it? Then there's the Big Bang. Cosmologists agree the universe exploded from a hot, dense state, but the details are hotly debated. Was it infinitely hot or astonishingly cold? And perhaps most puzzling of all, what triggered it? The prevailing theory suggests a period of rapid inflation immediately after the bang, a sudden, violent stretching of space-time itself. It's a useful idea, but it remains just that, an idea without direct proof. In 2018, a team of theoretical physicists from the Perimeter Institute in Canada proposed a breathtakingly elegant solution. They asked a simple, profound question. What if the Big Bang was far smaller and more symmetrical than we ever imagined? Their paper, published in the Annals of Physics, suggests that the Big Bang wasn't a beginning but a point of reflection, a cosmic pivot. Imagine our universe flying forward in time, expanding from that point. Now, imagine another universe, a perfect mirror image, flying backward in time from that same point. Before the Big Bang for us is the future for this anti-universe. This model requires a fundamental symmetry, where every action here is reciprocated there. This elegant idea has a stunning consequence. It removes the need for the rapid inflation period. The universe could have expanded naturally, more gently, over a much longer time, guided by this mirroring principle. But the most compelling part of this theory is its explanation for dark matter. We know of particles called neutrinos, tiny ghostly particles that barely interact with anything, streaming through you and everything else by the trillions every second. They are, in a way, their own kind of dark matter, but they're not enough. They're what we call left-handed, referring to their direction of spin. The symmetry of a mirror universe demands a partner, a right-handed neutrino. In our mirror universe model, these right-handed neutrinos would exist in our counterpart, but their influence would bleed into our cosmos, and because they only interact via gravity, they would be invisible. They would not reflect or emit light. They would be detectable only by their immense gravitational pull. In other words, the dark matter that has eluded us for decades, the missing mass of the universe, might not be some exotic unknown substance. It could simply be the shadow of a neutrino from a mirror universe, a particle implied by symmetry, felt only through its weight. Does a mirror universe running backward in time truly exist? It is for now a wild and heady idea. It may never be proven. But that is not the point. Theories like this are the lifeblood of cosmology. They are critical thought experiments. They provide a new framework, a new set of questions for scientists to explore, to challenge and to test against observations. They leave a trail of ideas, refining our understanding and pushing us to develop ever more sophisticated ways to observe the cosmos. Whether this specific mirror cracks or holds firm, it represents a beautiful and powerful step in our eternal quest to understand our place in the universe. It reminds us that the answers to our deepest questions might not lie in front of us, but in reflection, in the mirror before time. For a deeper dive into the science, read the original article by Caroline Delbert.